In this segment, we'll look at the main class of assemblies V1, which is process orders. And we'll introduce a major Java collection interface, map. Now, process orders includes method catalog, getCatalog, to read the catalog of components from catalog.txt. And this method returns, as you can see, a map object containing all the components. The main method down here calls getCatalog on catalog.txt and then extracts a set of key values from the returned catalog, which is a map, and iterates through them to get each component in the map. Now, keys is a set type, which is yet another Java interface. So before we go further, we need to understand the collection interface map, and then in the next segment we'll look at the interface set. Almost every library of collection classes, whether in Java or any other language, includes one or more library classes that maintain a collection of objects, and our catalog is an example of this, a collection of objects, each identified by some key value unique to that object. Examples might be a collection of student records with a student ID number as the key, or a collection of images with a unique image name as the key. Or in our example, and as shown here in the diagram, a collection of components, each identified by unique component names as the key. Now, you insert an object into the collection along with an identifying key value, and then you may later look up the object by its key value. So you can think of the collection as a set of key and value pairs, with each key identifying a value. If our catalog contained just 3 components, then this is how our map from string to component catalog variable would look. Now, collections like this go by various names: table, associative array, map. Java uses the term map. And each key value pair, by the way, is called a mapping. Collection classes provide a map interface describing the basic behavior, along with several concrete classes that implement the map interface, including HashMap, which implements map using a hash table, and TreeMap, which implements map using a binary search tree. If you want to get technical, it's actually a red-black tree to maintain efficient balance, but that's a detail we don't really need to delve into. Now, ultimately, you allocate one of those concrete classes. In getCatalog, for instance, we allocate a hash map. But virtually all the behavior of the map classes is described in the map interface itself. So that's the documentation to study. And of course, predictably, I'll ask you to study that documentation now. So here's the interface to look at and for you to look up in your own Java docs. And the first question is, what method inserts a new mapping, a single key value pair, into the map? And what does it do if there's already a value having that key in the map? And while we're at it, what method retrieves a value given a key? And what does it return if you give it a key that is not present in the map? And then finally, how do you check to see if a key is present in a map before trying to retrieve the associated value? So 3 questions in one there to think about. And if you've been looking at the docs, then you know the answer here is that, first of all, the method put, right here, inserts a key value pair in the map. And the method get, right here, retrieves a given object from the map, a value, being passed a key to identify that object. And if, by the way, there is already a key value pair with that key in the map when you do a put, then the old value is replaced by the new one, as it says right there. And for get, if the key is not present in the map, then it returns a null. And then finally, to test for the presence of a key in the map ahead of accessing it, we use contains key right here in the docs. Now, question 2. the map interface is generified, as you can see here. So declaring it requires type parameters. What types do you give in the angle brackets, and what's their purpose? And the answer here should be obvious from our code as well as from the documentation. The type of the key is the first type parameter, and the value type is the second. So in our case, for instance, it's going to be string and component. So with all that, it's pretty easy now to see how getCatalog works. First, it allocates a hash map, as we said, with key type string and value type component. Hash map implements the map interface using a hash table, so we can point the map reference, RTN, to the hash map, since it's a subclass. And then as long as there is more input, in.hasNext, the main loop in getCatalog reads another line of input, starting with a component name, which will be the key value for the new component. Then the loop determines if the component is a part based on the presence of a floating point weight value following the name. And if so, then in one expression, it reads the weight, creates a new part object, and a part component, and then inserts that new part component into the map with a return.put call. Creating an assembly down here in the else branch is a bit more complex. The else branch creates and fills a linked list of components to pass to the assembly constructor in the return.put call down here at the bottom of the else branch. The remainder of the input line from the file will be a series of names of existing components, which names will be keys, all of them keys, into the return map. So all the code must do is get each component from the map and add it to the list. So question 3, what does split do? Figure out what it's being called on, what this is in other words, and look it up in the Java docs. And why are we using it here? Well, the answer is split breaks a string, like the one returned from next line, into an array of smaller strings, breaking the larger string into pieces based on the delimiter provided as a parameter. So we're getting the remainder of the current line after the component name and breaking it up into an array of individual subcomponent names, one per array element. Now we've already seen Java's for each loop applied to collections that have an iterator method like list. It also works on simple arrays, iterating through the elements of the array. So this for each loop here iterates through each subcomponent name on the input line. And then question 4, what does the loop body do with each name? And a related question, what happens if we give a subcomponent name that hasn't yet been defined in the catalog.txt file? Think through the map methods we just discussed above and apply that to the loop body. The answer here is that the code first uses contains key to see if the subcomponent name is in the return map, and if so, in one expression, it calls get to fetch the component with that key or name from the map, and then add it to the pieces list. If the subcomponent name hasn't already been defined, it won't be in the map, and the code adds nothing. Error checking by the way of input is pretty light in Assembly's V1 since the focus is on design patterns and collection classes. Don't write code with this little error checking in the field. Now, in the next segment, we'll look at how map is used in the process orders main down here, and we'll introduce another new collection class interface and another design pattern.